The compound bow, a modern marvel of archery. The compound bow has revolutionized the sport of archery, offering significantly increased power and accuracy compared to traditional longbows and recurve bows. This article will delve into the key features and advantages of this remarkable piece of engineering. In modern archery, a compound bow is a bow that uses a levering system, usually of cables and pulleys, to bend the limbs. The compound bow was first developed in 1966 by Hollis Wilbur Allen in North Kansas City, Missouri, and a U.S. patent was granted in 1969. Compound bows are widely used in target practice and hunting. Compound bows are typically constructed of man-made materials such as fiberglass and carbon fiber. While traditional bows and warbows usually are entirely or partially made of wood or bamboo, the pulley/cam system grants the user a mechanical advantage, and so the limbs of a compound bow are much stiffer than those of a recurve bow or longbow. This rigidity makes the compound bow more energy efficient than traditional bows, as less energy is dissipated in limb movement. The higher rigidity, more advanced construction also improves accuracy by reducing the bow's sensitivity to changes in temperature and humidity. In literature of the early 20th century, before the invention of compound bows, composite bows were described as compound. Construction. A bow's central mount for other components, limbs, sights, stabilizers and quivers, is called the riser. Risers are designed to be as rigid as possible. The central riser of a compound bow is usually made of aluminum, magnesium alloy, or carbon fiber. Many are made of 7075 aluminum alloy. Limbs are made of fiberglass-based composite materials, or occasionally wood, and able to withstand high tensile and compressive forces. The limbs store the kinetic energy of the bow. No energy is stored in the pulleys and cables. Draw weights of adult compound bows range is between 40 and 80 pounds, 18 and 36 kilograms, which can create arrow speeds of 250 to 370 feet per second, 76 to 113 meters per second. In the most common configuration, there is a cam or wheel at the end of each limb. The shape of the cam may vary somewhat between different bow designs. There are several different concepts of using the cams to store energy in the limbs, and these all fall under a category called bow eccentrics. The four most common types of bow eccentrics are single cam, hybrid cam, dual cam and binary cam. However, there are also other less common designs, like the quad cam and hinged. Cams are often described using their let-off rating. As a cam is rotated, the force required to hold the bow in position reaches a peak and then decreases as the bow approaches maximum extension, a position known as the wall. The percent difference between the maximum force encountered during the draw and the force required to hold the bow in full extension is the let-off. This value is commonly between 65% and 80% of the peak weight for recently designed compound bows, although some older compound bows provided a let-off of only 50% and some recent designs achieve let-offs in excess of 90%. As the string is drawn, the cam turns and imparts force to compress the limb. Initially, the archer has the short side of the cam, with the leverage being a mechanical disadvantage. High energy input is therefore required. When near full draw is reached, the cam has turned to its full extent, the archer has gained mechanical advantage, and the least amount of force needs to be applied to the string to keep the limbs bent. This is known as let-off. The lower holding weight enables the archer to maintain the bow fully drawn and take more time to aim. This let-off enables the archer to accurately shoot a compound bow with a much higher peak draw weight than other bows. However, there are some youth-oriented compound bows with low draw weights that have no let-off and have a maximum draw length deliberately set farther than the majority of young shooters would reach. This effectively makes the bow function very similar to a recurve, with the draw length determined by the shooter's preferred anchor point. This removes the necessity to adjust the bow draw length or use a different bow for different shooters, or to change bows as the shooter gets older. An example of this type of bow is the Genesis, which is standard equipment in the U.S. National Archery in the Schools program. compound bow strings and cables are normally made of high-modulus polyethylene and are designed to have great tensile strength and minimal stretchability, so that the bow transfers its energy to the arrow as efficiently and durably as possible. In earlier models of compound bows, the cables were often made of plastic-coated steel. The compound crossbow is a modern marvel of engineering, blending the historical legacy of the crossbow with cutting-edge technology. It's a powerful and accurate weapon, favored by hunters and target shooters alike. A crossbow is a ranged weapon using an elastic launching device consisting of a bow-like assembly called a prod, mounted horizontally on a main frame called a tiller, which is handheld in a similar fashion to the stock of a long gun. Crossbows shoot arrow-like projectiles called bolts or quarrels. A person who shoots crossbow is called a crossbowman, an arbalister, or an arbalist, after the arbalest, a European crossbow variant used during the 12th century. Crossbows and bows use the same elastic launch principles, but differ in that an archer using a bow must draw and shoot in a quick and smooth motion with limited or no time for aiming, while a crossbow's design allows it to be spanned and cocked ready for use at a later time and thus affording them unlimited time to aim. When shooting bows, the archer must fully perform the draw, holding the string and arrow using various techniques while pulling it back with arm and back muscles, and then either immediately shooting instinctively without a period of aiming, or holding that form while aiming. Both demand some physical strength to do so using bows suitable for warfare, though this is easier using lighter draw-weight hunting bows. As such, their accurate and sustained use in warfare takes much practice. Crossbows avoid these potential problems by having trigger-released cocking mechanisms to maintain the tension on the string once it has been spanned, drawn, into its ready-to-shoot position, allowing these weapons to be carried cocked and ready and affording their users time to aim them. This also allows them to be readied by someone assisting their users, so multiple crossbows can be used one after the other while others reload and ready them. Crossbows are spanned into their cocked positions using a number of techniques and devices, some of which are mechanical and employ gear and pulley arrangements, levers, belt hooks, pulleys, windlasses and cranakins, to overcome very high draw weight. These potentially achieve better precision and enable their effective use by less familiarized and trained personnel, whereas the simple and composite warbows of, for example, the English and the steppe nomads require years of training, practice and familiarization. These advantages for the crossbow are somewhat offset by the longer time needed to reload a crossbow for further shots, with the crossbows with high draw weights requiring sophisticated systems of gears and pulleys to overcome. They're huge draw weights that are very slow and rather awkward to employ on the battlefield. Medieval crossbows were also very inefficient, with short shot stroke lengths from the string lock to the release point of their bolts. Along with the slower speeds of their steel prods and heavy strings, despite their massive draw weights compared to bows, though modern materials and crossbow designs overcome these shortcomings. The earliest known crossbows were made in the 1st millennium BC, as early as the 7th century BC in ancient China and as early as the 1st century AD in Greece, known as gastrophetes. Crossbows brought about a major shift in the role of projectile weaponry in wars, such as during Qin's unification wars and later Han campaigns against northern nomads and western states. The medieval European crossbow was called by many names, including crossbow itself. Most of these names derived from the word ballista, an ancient Greek torsion siege engine similar in appearance but different in design principle. In modern times, firearms have largely supplanted bows and crossbows as weapons of war, but crossbows remain widely used for competitive shooting sports and hunting, and for relatively silent shooting. In an apocalyptic scenario, when social systems collapse and supplies are cut off, self-defense and survival become extremely important. Power bows and power crossbows, with their advantages in accuracy, power and mobility, can become useful tools to deal with extreme situations. In an apocalyptic scenario, as social systems collapsed and supplies were cut off, self-defense and survival became extremely important. Power bows and power crossbows, with their advantages in accuracy, power and mobility, can become useful tools for dealing with harsh situations.